Hey, welcome back to our help videos of our Test Premier Unit 8. This is the objective part of the test, 8-20. And in our second video, we're going to pick up with questions 5, 6, and so forth. On number 5, we need this activity series right here. In this activity series, magnesium is our most active, then zinc, cadmium, hydrogen, and our least active metal in this list is silver. Remember, active metals can replace less active metals from an aqueous solution in a single displacement reaction. Now we're looking at some reactions down here, and they're asking us which one of these following reactions would occur as shown. So we're looking for the one that is actually going to take place. In letter A, we have a piece of magnesium being dropped into a solution. Aqueous means that water's pulled apart this into CD or cadmium 2 plus and sulfate 2 minus ions. We know it's cadmium 2 plus because sulfate's 2 minus polyatomic ions. So we have cadmium ions floating around. Can magnesium replace the cadmium ions? Well, we come up here, we see magnesium is more active than cadmium. So what that means is when magnesium's dropped in the solution, cadmium's 2 plus, so that it can take 2 electrons. Magnesium's an alkaline earth metal. Alkaline earth metals are family Roman 2, group 2. They have 2 electrons. So that magnesium will force the less active cadmium to take those 2 electrons. So now magnesium had 2 electrons. It got rid of them. So now it is 2 plus. So water, being polar, is now able to grab onto magnesium and hold it in solution. Magnesium sulfate, aqueous. Cadmium was 2 plus, but after magnesium forced its electrons onto him, cadmium went to neutral charge in the polar water molecule. The partial positive oxygens on water molecules cannot grab and hold the cadmium any longer, and it'll precipitate out of solution. What did the sulfate do here? Absolutely nothing. The sulfate was 2 minus. The sulfate ion is still 2 minus. It was not involved in this reaction at all. It's a spectator. In this next reaction, letter B, they show zinc. And what are they showing happening here? What they're showing happening here is zinc apparently is forcing the nitrate ion out of solution. Zinc does have 2 electrons. Zinc is a fairly active metal. It is good at dumping electrons off, but the nitrate ion is already 1 minus. It's not going to take additional electrons from zinc and precipitate out of solution. It's not going to happen. A metal cannot force a nonmetal out of solution. It would force silver out of solution, but it's not going to leave silver in solution. In letter C, what do they show happening? In letter C, they show silver, which is the least active of the metals. They show silver forcing zinc out of solution, which is more active. It's not going to happen. That would be a no reaction. On this next reaction, letter D, what's happening? Here we have cadmium, a piece of solid metal, being dropped in, moderately active. But what they show cadmium doing in this reaction is forcing iodine out of solution. Well, HI is hydroiodic acid. It's one of our strong acids. It will dissociate at 100%, meaning that we'll have H pluses and I minuses floating around. Cadmium is trying to get rid of electrons and force other substances to take those electrons. Iodine already has an electron. A metal is not going to replace the non-metal iodine. Metals will always take the place of the first thing in the compound, not the second thing. As we see here in letter A, magnesium's replacing cadmium, the first thing, not sulfate, the second thing. So the correct answer is letter A. Number 6, which one of the following statements is false? We kind of alluded to some of those tests up here when we talked about in the first video about how to prove oxygen's a product, how to prove carbon dioxide's a product. We didn't talk about how to prove hydrogen's a product, though, and we probably should have, but we will down here. Which one of the statements is false? If you have a burning splint and you blow it out and you insert it into a test tube and the red embers on the splint reignite, is that a proof that oxygen is being produced? And the answer is yes, that is true. And that's how one way you could tell oxygen's produced in this reaction right up here. We have oxygen being given off. If you have lithium chlorate and you're decomposing it in a burner flame, oxygen comes off. If you have a splint and you blow it out and you insert it into that test tube, it will reignite. The second test there is the sugar test, where, and this one's a little more exciting to watch, that's the one where you could throw Skittles in there and the Skittles would burst into flames, or gummy bears in there. Sugar burns actively in the presence of oxygen. All right, letter B, a burning splint's brought to the mouth of the tube and you hear a loud barking or popping or exploding noise. Hydrogen is a product. Yes, that is a test. What's the exploding or barking noise? The popping noise? That's hydrogen combusting. So if you wanted to prove, if you drop magnesium in a solution of hydrochloric acid and you want to prove that hydrogen's a product, you can catch the hydrogen bubbling out of there in a test tube, and you can insert a burner flame near the mouth of it, and that hydrogen will burst into flames. Letter C, you insert a burning splint into the tube, and the splint is extinguished. CO2 is a product. Yes, that's the test. That is one of the tests that you can do. In this reaction right here, letter B, they're decomposing the carbonate ion. How can we prove carbon dioxide is produced? One way is to insert a flaming splint in there, and if the splint goes out, that's evidence that carbon dioxide produced. The other one is to collect that carbon dioxide gas and bubble it through lime water. That CO2 will react with the lime water, and you end up having the CO3 carbonate ion being produced, and the carbonate ion is going to be insoluble, and you'll see a white precipitant form. The lime water turns a milky white color. That's the lime water test. Number 6. Oh, here's what they're talking about. A reaction produces gas. Gas is bubbled in the lime water turns cloudy. It's kind of a white cloudy color. The gas is an acid. Oh, no. That's the second way that you can prove the gas is carbon dioxide. All right, number 7. Which of the statements is false? Acid-base neutralization reactions and combustion reactions both produce water. They do. They do both produce water. Acid-base neutralization reactions produce water and a salt. Combustion reactions produce water as a vapor, as gas, and they also produce carbon dioxide. Oxygen is one of the reactants of a combustion reaction. Well, here's a combustion reaction right up here. Here's a combustion reaction right up here. There's the oxygen. Yes, it's a reactant. There's water for the other question. It's one of our products. Yes, oxygen's a reactant. Spectator ions are present during the reactions, but they don't participate. That's a true statement. Aqueous means you must dissolve it in water for the reaction to occur. Oh, yeah. Aqueous means that water is going to have to be there to pull apart a salt. So in this reaction right here, why does it have to be aqueous? Because in order for the magnesium to force cadmium to take electrons, the cadmiums must be pulled off the sulfates. Then they can take the electrons. Double displacement reactions can be categorized as redox. No, in a double displacement reaction, every ion in that reaction, sometimes called net ion exchange, the ions keep their charge. Everything's charge stays the same in a double displacement. For that reason, if the charges stay the same, the oxidation numbers stay the same, because the oxidation number is always equal to the ionic charge of a substance. It can't be redox because in a redox reaction, oxidation numbers change. Do double displacement reactions sometimes produce an insoluble solid? Yep, that's one of the driving forces. The insoluble solid will precipitate from solution. Can they produce gases? Absolutely. That's the second driving force. Can they produce water? Yep, that's the third driving force. These are the three driving forces of double displacement or net ion exchanges. Water is produced in the special category of double displacement, which is called acid-base neutralization reactions. In a single displacement or replacement reaction, are they redox? Yep, they will always be redox because in a single displacement, on the left side, you always have an element, and on the right side, you'll have a different element. So in this reaction right here, we have fluorine by itself, right over here, we have fluorine by itself. Now it's in its compound. It went from 0 to -1. Here we have bromine at -1. It went to 0. Single displacement. Their numbers changed. Down here we have single displacement. Element, compound plus element and compound. Magnesium's replacing cadmium. Here magnesium's 0. Here it's 2 plus, so its oxidation number is +2. Here cadmium is 2 plus, so its oxidation is +2. Over here it went down to 0. Single displacements, the oxidation numbers always change because the ionic charges are changing. Catalysts speed up reactions. Letter AD, that one's true. And now we're into a set of questions where we are going to be determining an activity series, and we will do this on the next video.